Well, I'm ready to try this again. I just connected the filter capacitor, and basically the schematic, which is all messed up, says it's an 8, a 12, and a 16, so I went with a 8, a 12, and a 22, because they don't make 16s. And what I did is I put the 8, I went from green to white, green being 8, yellow 12, white 16. So as it gets closer to white, the value's going up. So I don't know if I got them in the right place, but I put the green here since it was by itself here, and the other two connected to the two cathodes of the 25Z5 rectifier. So that's the white and the yellow here. Yeah, and everything's suicide connected. I got my capacitor connected in across the filament string, and I've got the 110 going to the filament string and also to the switch. Suicide connected here. I got my voltmeter, which is tied to one of the heaters, the heater of the 6A7, which is 6.3 volt heater. They're all in series, so I can monitor the voltage there, make sure I don't get up to 6 volts, and that way I know that the heaters have the somewhat right voltages. And I connected my suicide antenna here. So let's give it a shot. It's on. So I'm going to bring the voltage up until we get a decent voltage there. Of course, the tube's going to start conducting as the voltage comes up. As long as I don't go over 6 volts, we know that the heater string voltages are okay. It should start conducting pretty soon. I'm going to just keep it down around 4 there. I'll watch it and make sure it don't go up too high. It is still going to climb. The tubes are conducting. Pilot light's lit. And there we have a radio. There'll be a little bit of a hum. Of course, these capacitors are sharp in here. We're holding fine on the voltage. And if I bring the voltage down a little, some of that might go away. Yeah. All right, I'm on 81 volts, which is enough to run the radio. So the only other thing I can do now is try a different arrangement on the filter capacitors and see if we can get rid of that hum. Let me get it off the channel so we can hear the hum. And I'm going to switch these two and see if that does anything. I got to be careful I don't shorten it out. Oh, just taking that off got rid of some of the hum. Okay, I'm going to move that one over. Move it over to there. Okay, that's worse. So it looks like that one does go there. This is the two cathodes, by the way. That got rid of that hum. Maybe I need to switch the green, the 8, with this 22. The 8 is really funky to get to here. Holy moly, that got rid of all of the hum. Let's connect that one there. That's good. Get back on the channel. I'm not getting nothing. I can find the channel. Oh, the voltage dropped. And my voltage is dropping. let me go ahead and put this one where, and watch those wires there too, where the other one was. And start the voltage back up. And if I take that off, we lose our voltage. Okay, so we definitely need one there. But not, let me see if I bring that voltage up a little bit. No, that's not making no difference. So we definitely need one across there. The question is what one? Obviously not the 22. Let's see if I can get the yellow one across there. Don't you touch that. Geez, that would be a big problem. Okay. No, not working. Thing's slipping around. There's voltage on that, so I don't want to play with it. Let's try the white one over there. No. Yep. That brought that down. I just don't know. I don't know what those values should be. All right, I'm going to shut this off so it's not as dangerous. And I'm going to switch these two back. These are the two cathodes, these two wires of the rectifier tube. And so if I put the lowest two on those, which would be the green and the yellow, they need an 8 and a 12. We put that on them, and we put this one back over here. Put the high one on there. Let's see what that does. Turn it back on. Back up. Sorry for the glare. I should stop conducting pretty soon. Right. Not the right values. Okay. So let's see. It did better with the smaller one here, the 8. So we're going to put the 8 back down there. And see, I'm going by a schematic that's not the right schematic. And let's put this one here, back over here. So now we got, and of course, you know, I've got a capacitor in line to drop the voltage. So that, I don't know if it's interfering or not interfering, but it shouldn't be a hum. That's fine. Let's try that. That's better. I don't know. Maybe the answer is I go ahead and recap it and eliminate the possibility that any of these capacitors, including that big boy there, is causing an issue. Those caps seem right. They could be picking up interference. Don't seem to be from my light source. They could be picking up interference, but I don't know if they're the right value. I get some feedback through my light up here. That ain't it. So I don't know. See, right now I'm down to 65 volts. I bring the voltage back up. I'm getting hum from the line. Now the tubes are conducting again. Okay, let me shut that off. Here's the issues, and I think I've explained it once before, is you got this choke coil and that goes to ground. You have three capacitors here, an 8, a 12, and a 16. The negative sides all connect together and they go to ground. That makes no sense because that takes this coil out of circuit. But that's not what's happening in the radio. In fact, they're showing these two capacitors, the 12 and the 16, go into one cathode. Again, that makes no sense. You got two cathodes and two plates. It's half-wave rectification. You wouldn't be using, it's full-wave rectification. You wouldn't be using half-wave rectification only and running the other half through just this speaker coil here. I doubt it. Unless this half is, no, that wouldn't make any sense. You wouldn't do that. It's more, and that's not what was in the radio either. These two don't connect together in the radio. The capacitor that's in there has all three grounds were connected together because there's only one negative coming out of the can. So there's only one wire instead of three, which means they're connected together. One of them does go to this coil, and it does connect to the speaker output transformer or the field coil. I'm not sure which because of the way it runs through the chassis. I didn't trace it. But one of them connects to a coil, okay? The other two connected to both cathodes, one to one cathode, the other to the other cathode, which makes me think that those two should be the same. But not necessarily, because let's say that this 16 goes to this cathode and up to this 5 meg resistor. That would make sense. And then the 12 could probably connect here, go to the other cathode, and the reason it'd be less is because it's also going through this coil. And so you would need the full 16. But again, I don't know for sure because of the way the schematic's drawn. It makes no sense. And the values of the filter capacitor in the radio were totally dead. I was getting 5 nanofarads on one, 4 nanofarads on the other, 5 nanofarads on the third. So they were dead. They were 0.004, 0.005, and 0.004, which is, two 0.005s and 1.004, which is an impossibility. They're definitely up in the 8, 10, 12, 16 range. I don't know. It's a 1935 radio. These values definitely seem right. Unfortunately, that's not the exact chassis that's in this radio. The schematic says it's a 60A, but it's not a 60A. It's not this schematic. Maybe I just need to look around and see if I can find another schematic for it, one that seems to match what I'm seeing in this circuit, because this is not right. This one has definitely got a problem here. This is wrong. There's no way you have a coil going from ground to ground. This is ground and this is ground. That's a useless coil. It ain't doing nothing. That choke would be useless. It's like connecting it to itself. It's useless. So that's definitely wrong. It doesn't make sense that they would put a 12 and a 16 in parallel and connect them to the same line. That just doesn't make sense either. And in the radio, they're not. Yeah, the 8 by itself on one cathode, that makes sense. One of these on the other cathode would make sense. The other one, I don't even know where it would go. And if I put one to one cathode and the other to the other cathode, which we just did, and I disconnect the third one, the radio doesn't play. The third one has to be there for this coil, for the speaker coil. So I'm going to try to see if I can find another model than the 60A and see if we can find this chassis. The other thing, if I can't find the chassis, I just need to make it work. And to make it work, I have to figure out what are the values of capacitors that are in this can. The can isn't marked. And so, well, it is marked, but it's marked with codes, like a part number and stuff. It doesn't say the value, but it is bolted in. There's a bolt here and one over there. I can unbolt it, take it out, and see if I can make heads or tails out of the number. See, there's the other one. This is the ground that went over to where that black wire is. So that's the ground, and the other three, one went here to this tube here, and the other two went up here to, well, that's them there. I just cut them basically and pulled them through, and that's them, and they go to the two cathodes of the rectifier tube. Okay, I've been playing around with capacitors and switching them back and forth, trying to find out for the three areas that the old capacitors were connected, what works the best. And so far, this is what I got, which I'm powering up the radio now. I'm letting the voltage climb. Should start hearing something any second now. The tubes are beginning to conduct. I only have 3 volts on the filament, so I'm running it a little low. Let me kick it up a little bit more. I don't want to overcook the filament, so I'm being very careful about that while I do this experiment. Okay, now we got some hum, but that's the lowest I've had to hum, and it is independent of the volume control. So the volume control has nothing to do with the hum. I'm not on the station here. Okay, and here the radio is playing good. Okay, so that's the volume of the hum, and to get it that low, what I've got right now is I have the 8 microfarad going to where the choke is in that area. I haven't checked the choke, but this is where the original filter can capacitor was connected. It was connected there and to the 2 cathodes of the rectifier tube, which is back here. Okay, so I've got 8 microfarads going to the choke. If I disconnect that, the radio goes dead. Has to be there. So we definitely need the capacitor there, and the lowest of the 3 on the schematic, which was a 8, 12, and 16, is there. I found that if I increase it to say, okay, that's an 8. If I put a 10 with it, the hum actually gets worse. However, so the lower I go, the lower the hum goes, but the lower the volume goes, and the lower the radio reception goes. So going lower than 8 is not good. If I increase it, I'm going to try to do this here. Actually, that's better. Okay, that's with 18. That opposed to that. Let's see what that does to the radio. No, can't get the radio without this on. I gotta find the station again. Hold on, let me clip this better. Just drop that in there so I can find the station. Okay, I can't leave it on the station because of the YouTube police. Okay, so you hear that, and when I'm off the station, you hear the hum. Actually, that's not bad. The hum isn't really bad. Maybe some of these other capacitors are forming. All right, let's try the 18 again. Okay, it's dropping the voltage, down, the volume down. So I'd rather stay with the 8 because that's working. All right, let's get off the station. That ain't bad, actually. Okay, let me tell you what I got going on. We just looked at the 8. On this cathode of the rectifier tube, I have 10 microfarads, which the next one up in line would be 12, but I got 10. If I put the 12 in its place, so we take the 10 out. Well, that's weird. Before that was making a difference. It is, it's making a difference. The volume's lower. Yeah, okay. So if I take the 10 out and put the 12 in there, got the wrong side going to ground there. Try it again. Okay, the hum is that volume. Hold on. These are going to be charged up, but I can handle it, I think. I'm going to go ahead and connect these both so we can troubleshoot this particular cathode. Okay, here's the 10. and here's the 12. 10, 12. About the same. Ten may be a little better. Actually, the 10 is a higher frequency. 12 is a little bit lower. So that's an either or. Let's say we use the 12 since it's on the schematic. We'll put the 12 there. Okay, so now we've looked at this one near the choke, and we looked at this particular cathode of the rectifier. The other cathode of the rectifier is back here. It's this red lead comes around to over here. On that, I have 66 microfarads. I've got two 33s in series, in parallel, so that's 66. That has eliminated the hum the most, and at the same time has not eliminated the volume, but that's awfully high. Whatever, it doesn't matter. We're filtering. We're not worried about values. We're worried about getting rid of as much hum as we can without affecting the volume of the radio. Again, remember, the hum is not controlled much by the volume control. Actually, that's static. So the hum is not controlled by the volume control at all. If I was to put the 66 on this cathode instead of that cathode, you'll see what happens here. I take this off. What does that do to the... We already seen that that affects the volume of the station. Okay, so if I take that off and I put the 66 on that one, the hum gets a whole lot worse, even if I connect this back up. It's a whole lot worse. So it wants 66 on that cathode. See the difference? Without even this connected, the hum's almost completely gone. Now this one, without it, the hum's lower, but so is the volume, the reception. With it, the hum's a little bit higher, but the reception is better. And actually, when I say the hum is a little higher, it's almost like it's, oh no, I guess it's the same frequency. Okay, if I increase this one, okay, we've got 12 on it now. If I add an additional 10, see, the hum gets louder. So 22 is worse. And in the station, there's no effect to the station, to the sound. I wish I could find an all-talk radio. I could just leave it there, but I can't. And unfortunately, the YouTube police will come after me if I leave it there. So 22 doesn't work here. 12 works, 10 works, 12 seems to work a little bit better than 10 or about the same. But you go up, the hum gets worse. This one, if you come down, the hum gets worse, and it's at 66. If I increase it, let's try adding another 10 to it. So if I add 10 more to it and make it 76, there's no change. So taking it up from 66 doesn't help. I had it at 22, the hum was worse. I had it at 47, and it was pretty good. And if I add 47 to it now, see how that actually helps? Now that's 66, and that's another 47, so that's 100 and something. That's just unreal. And it might be that there's a hum induced in the circuit from something else, and this higher microfarad is pulling it down. See what that does to the station. No effect on the station, but 100 pulls the hum down. Isn't that something? Now I could put 100 in there. I think what I'm going to do, though, is not worry about that too much now. I know what I can do with it. I'll just leave them dangling like they are and switch out these capacitors. And then we'll do another test and see if there's an improvement with new caps or a decrement. And if whatever there is, then we will fine tune the capacitors to get rid of the hum. And then once we do that, then we can, raise the voltage up. I mean, this radio is playing pretty good for 3.5 volts on the tubes. It's a very good radio. I mean, that sounds great. And Ian has a whole lot more volume than that. Now, it does get started if I raise the volume, but we got wax capacitors, and that's why. That's a big part of it, I mean. So I'm going to go ahead and shut down, change these caps out, and then we will continue this video and continue this diagnostic. I hope you're finding this interesting. I sure am. It's been fun dealing with this, and I'm looking forward to actually doing an alignment on this radio. I think this is going to be a very powerful radio. So let me pull that down, shut it off, and we'll let these capacitors discharge. Hopefully none of those tubes are, nope, none of the tubes are hitting the plastic, so we're good there. So I will be back. Well, I went ahead and hooked this up to the scope so you can see the waveform over here, and that's the noise, the hum. So, looks almost like a sawtooth, kind of weird, huh? And it's got a dip on each one. Of course, I'm pulling this off of the plate of the output tube, so this is the actual signal going into the output transformer. I know that seems like a lot. I've got the voltage up, but we go to the station, you can see how the station pretty much eats that up, right? It's just the background noise right there. So if I disconnect this one, we get a sawtooth, which is really weird. That's the 8. And I can fine tune that and maybe flatten it some by changing this value some. We get almost a square wave there. If I disconnect this cathode capacitor filter, we get a square wave with a spike on the top. So it's sort of rectified, but it's there. All right, can't leave that there. We got a great sawtooth on both cathodes, but we got 60 hertz hum in there. Well, anyway, I'm going to go ahead and change these capacitors. I just wanted to look at it at the scope before I made changes so we have some reference. Okay, thanks for watching.